Hey guys, this is Ostrus. Today we're going to try to train a LoRA with Flux.1 Kontext. This just came out yesterday. I spent the entire day adding it to AI Toolkit, and see that over here. So we're going to train a LoRA today with it. So there's a few different ways you can train LoRAs with this. You could do just straight style where you don't have a paired image set. So this would be like your traditional training. So you're just going to teach the model concepts. FluxDev LoRAs don't work great with it. They'll kind of work with it, but really fine-tuning a LoRA directly on this model itself will work better. If you do pure concepts, and this is the way I think a lot of the cloud trainer people are doing it, you're going to not have the same effect. So you'll lose some of the reproducibility in the image. It won't be a perfect one-for-one because you're just teaching it a concept. It doesn't really know what to do with that. And as you train it, it's going to break down if you don't have the control pair. That being said, to get started, you can come over here to AI Toolkit. Today, we're going to be using runpod as a cloud compute, but there's a link in the description for this. You can come down here. They'll tell you how to install it for Linux, Windows. Won't work on Mac. And that's it. Once you do that, you'll be up and running. Or if you want to do a cloud compute, that's what we're going to do today on runpod. If you're going to use runpod and you haven't signed up, I'll have an affiliate link in the description. Please use that. Just gives me a little extra compute. So let's come over here. You can go to runpod, sign in, do all your stuff. I'm going to come over here to pods. I'm going to train on a 5090. This is now pushed to the main branch, so we can just select that. Everything works with the 5090. So we want to change template. I have the template already loaded, but yeah, if you do AI Toolkit, there's the official one. That's the one you want. That's the one that I maintain. Then you're going to want to edit the template, okay? So if you come down here to public environment variables, here's the password. So this is the password. So to protect your service so people can't just find it, because it is exposed to the cloud on here. So right now it'd just be password if you don't change it. I'm going to actually change it to, I have a secret set up. You can just type it in here, but I'm going to use my secret password. Other than that, the rest of these settings should be fine. Set the overrides. AI Toolkit on a 5090, 32 gigs of VRAM. Nice. Let's deploy. Okay, we're ready to go. The container started. So we just have to click connect here. And this is our web service. So this is the AI Toolkit web UI. It'll open up, enter my token. And we are in. Okay, so we see we have our NVIDIA GeForce 5090. Perfect. For my data set, we're going to do big head again. I've done a video on big head before. I just didn't want to have to create a whole data set. If I'm being honest, I wanted to get this information out here. So we're going to come over here to data sets, and we have to create our pairs. So for doing this in a way that you're going to have targeted editing, you basically you have to spend some time making your data set, because you have to teach it exactly what you want it to do. So on this, we want to have big heads. So you have to have a big head data set. So we'll do our target. So this is what we want our instruction to be like. So we'll do big head target. Cool. And then we're going to need another data set. Let's go back. We need one called big head. And this is going to be our control image, or this is the image we put in, our initial image. Or our initial data set, I should say. Okay. And then, so we need test images. I'm going to add some features to make this easier to do, but to get it out, it's a little complicated right now. So we're just going to put test. And that's where we'll store our test images, just so they can be on the computer so that we can access it. All right. So we want to come over here, big head control. This is our initial image coming in. Remember, this is the control image is what the model sees, and then we're going to tell it what to do. So for our control images, I already have some prepared. I'll drop them in. I'll put a link to this video. This is when the AI Toolkit UI first came out that I made this data set. Yeah, so control image, we don't need any prompts in the controls. It's just pulling in the images. So we're going to feed these images in. We're going to give it the instruction, make their head bigger, and then we'll have the target right here. And this is the one with the edited ones. So I pull these up. Okay. Drop those in. Okay, and that's good. So our other one, they have small heads. These have big heads. These have the exact same file name. So 2 different folders. You have your target, which is the edited. You have your control, which is the regular image. And these we do need to have captions here. So we're just going to put make her head, if I could type, big. Let's do big. Make her head big. So I'll put it on all these. I'll change the her to him. And then his. Her to his, I should say. Make his head big. Make his head big. Okay. Make her head big. Make his head big. Her. Okay. So that's our whole data set. And remember, this is the target. You only have to caption the targets. And now, just because I'm not on a local computer, I need to test, because you have to have, when we're generating samples, you want to have test images. Let me find these. I went ahead and pulled some, and I made them square. It's just easier. Crop them all so they're the same size. And they don't have to be the same size, but they have to be the same aspect ratio. So you want them all square ideally, just so that way when you generate the image, you can just tell it to be square for all of them. All right, perfect. So we have all those. It's good. We don't have to caption these at all because we're just going to reference them. Now, I don't have an easy way to do this. I know the file names, and I know this data set is test. So we're going to have to do something a little hacky here to get the paths. The file names are just 0.1 JPEG, 0.2.jpg, etc. So you can probably do this easier on your computer. If you come to this link, I'll post this in the comments as well. You'll have to accept their terms, and then you're going to have to generate a new token. If you already have a token, you can skip this part, but I'll show you how to do it if you don't have one. Settings, and then we want access tokens. Okay, I already have a ton of tokens. We're going to create a new token. We just need a read token. That's it. And we'll just name this one Toolkit Demo 3. Apparently I've done these before. Create token. Here's my token. So you want to come to your settings, and here, your Hugging Face token, just paste that in right there. Save the setting. And then it'll be able to pull the model down. I'll try to find a way around this, but unfortunately, that's the process you have to do. So you come, click on New Job. Okay, so we're going to come over here. Let's name this Kontext Big Head. And we don't need a trigger word because it's in our prompt. That's fine. And then we're going to do Flux context. We want to quantize everything. You can leave most of this the same. We'll do 3,000. I'm just going to do 4,000 steps just because, hit it with a hammer. So here's our data set. This is where we have to do some kind of tricky stuff. So our data set, since this is a context one, when you select this, it gives you this extra control data set. You can click here, kind of explains a little bit how control data sets work. So we don't want our control here. Here we want our target. So the data set will be our target. This is the ones with the big heads. Our control data set is what is fed into the model. So we want this to be our control. Okay, perfect. Other than that, we have captions on everything. We don't need that. If you are doing on a 4090, you will not be able to train at 102.4 on Kontext. The way Kontext works is it actually kind of basically runs the image side by side. So you're actually generating an image twice the width or twice the height. When it's packed, it works a little differently. But so it's like generating an image with twice the pixels. So training, twice the pixels. So this is going to probably on you if you have a 4090 or any kind of 24 gig. So just go ahead and unclick that and just keep it at 76. I have a 5090, so I'll be fine. Come down, this has this extra little prompt here, and it shows you how to do this. This shows up if you're doing context. So it tells you, control image to the control image path. So one thing we can do here, we'll go back to our data sets, open that in a new tab. Okay, so we're going to come here to test. Okay, so these are our test images. So what I'm going to do, we can come back to training, and I know I have 5, right? So we only need, actually I have 6. So 1, 2, 3, 4, 5, 6. Okay, so we'll just erase these, and I'll put give this person a big head. All right, and then we got to do dash dash. And in order to see where our data sets are here, we can just come to the advanced tab. And you can see the data sets here. So this one is for the big head target. I'm going to go back to simple. So it'll be it says right here, control. And again, I'm going to make all this easier. But for now, data sets, and we have it in test. And my images are 01.jpg. Perfect. So I can just copy this one. I'll do it for all of them. And we'll increment all these. 01, 02, 3, 4, 5, 6. All right, so we're going to create this job. We're ready to train. Let's go ahead and click play, and it's going to have to download the model the first time because we don't have it on our cloud thing. And once that gets done, it'll generate our first sample so we can see what the model already knows and fine tune it, because it may already know how to give people big heads, and I've wasted my time up to this point, in which case you won't be seeing this video. So you kind of know in advance it doesn't do a good job if you're seeing this, but we'll see. One thing, if you get an error here about how it can't find the repo or it's gated, you still need, then that means you need to come back over here. You need to make sure you do the gated model, make sure that you add your token. Information on how to do that is in the AI Toolkit repo, somewhere on here. It tells you how to do it for dev, but same thing works. For this, you have to agree. Even if you agreed to dev, you need to come and agree to the context one. First one's done. All right, so it does not know how to give people big heads. So this is good. Everything's kind of over contrasted, and this is one of the things I wanted to bring up. So because of the way that we are training it, so if you use some of the cloud trainers, they do something where it's just you're training a style. So you basically use traditional training, and you can do that on here too. Just feed an image data set, treat it like Flux Dev, and should still work. But you can tell how there's this weird contrast. It's over contrasted, and there's almost this weird line here because they clearly had a different sizing, a very specific sizing when they were training it. So you get kind of these weird artifacts. And that's one thing about using the context model. If you use the pro model, you'll notice that there's all these weird artifacts in all the images. One of the great things about fine tuning it is we're going to clean all that up with our fine tune. So not only do you get to do new concepts, but you're actually going to get better results by fine tuning your own for a specific task. So none of these people have big heads. Just not doing it for anyone. And we got the Skeletor. if you're not seeing your images here, then your image path could be wrong. The one that you set up on the samples, the control and image, because it should be very similar to your image, if not the same image, and all these are the exact same images. Like these, other than these artifacts, some of the over contrast stuff, everything else is exactly like my image. And I picked these ones for a few reasons. One, hand on the head, I want to see what it does there. Is the hand going to move? Because I don't address that in my actual training data. So I really want to know how that works. Are the glasses going to scale? Or are they going to shrink? We'll see. I want to see if it can do a group. How do these big heads affect in this whole group of people? Because I don't have any groups in my training data. This person's wearing a costume. There's also a head on a stick here. Real curious how that's going to work. You can also still see there's definitely a size that they trained on that hit a limit. And so it's getting new area here that it normally hasn't seen. Yeah, this guy has his hand in front of his face. He's smoking. Real curious how that's going to affect it. This girl's looking in a mirror. Is this head going to get big, or is it just going to be this one, or is it going to work at all? This guy had actually made his head a little bigger. That's surprising because none of the other ones did. Okay, so this is the original image here, and you can tell it made his head bigger. That's really impressive. So I think that's the only one, though. I mean, none of these other people look like they have big heads. So we'll let it run, and we'll see where it turns out. We are getting close to some new samples. So you can tell this is going kind of slow. I mean, even on a 5090, we're looking at around 5 seconds an iteration, and some of that's because we have small images in our data set. And look at the load here. It's 30. It's dropping now because it's sampling. But we were at 30 gigs of VRAM. That's because we're using the 1024 image size. So you're not going to have that with the 4090. You won't be able to do that. But you will be able to do, 768. Okay, first samples are done. Let's come take a look. Let's see what we got. All right, so this is where we started. Let's see. All right, heads are getting bigger. You can also tell here, all these like weird artifacts like that base model has are kind of cleaning up, which is nice. It's looking like a less weird, choppy image. Yeah, head's bigger. I really want to know, see, it's kind of filling out her hand here. I'm really curious if that hand's going to go up, or see how it kind of pushed her body down. Is it going to keep pushing the body down? I have no idea. We'll see. Okay, we got this one. Not much has happened between 0 and 1. In fact, by not much, I mean absolutely nothing has happened. But we don't have any group photos. And this is a test one. I want to see if it's only going to work with one person or if it'll work with a group. So this one doesn't have a real face in it. It did clean up all the artifacts. It's still cleaning them up, but nothing seems bigger. Maybe it's a little bigger. Really, it's just the proportions are changing. See, this guy, nothing has happened yet. Oh, yeah. Okay, so that one's clearly working, but notice it's only affecting her head here, right? This one's not changing, which is, quite interesting that it's only doing that face, but it's still early. We'll see. Okay, so the old man, it was already kind of making his head bigger, but now it's doing it better. Again, there's some of these little artifacts. Those are getting cleaned up. It is kind of breaking the cable, so I don't know if that'll continue to happen. We'll see. Our next group of images are in. Let's see. So head's getting bigger. The hand just went behind the head. That's kind of what it probably should do. I'd rather that than it going into the head. So that's good. It seems to know what we're doing, understands the concept. Let's see, so we have this group. Okay, so I guess it's kind of a mix of this dude, and it just kind of put his head there. It's not doing that girl. Probably need a group photo to really make that work. But this enormous person is still behind these people. So, yeah, I'll count that as a win, I guess. I don't know. This image, it's still cleaning up the image, compared to the artifacts that were in the first part of the native, but it's not doing anything with that. So we may have to do one with a mask. I mean, this is one of the things. You want to find the weak points. Okay, so the first two, nothing happened. Now his head is getting a little bigger, right? His fingers are moving a little bit, but we're seeing some progress. So she's continuing to get a bigger head. The other foreground head's not doing anything. Then this old guy, it's cleaning up his big head. Okay. It reconnected the microphone cable. That's good. Awesome. Let's keep it going. I just absolutely love coming and looking at the samples. Training is just so much fun, and you get to see it going and you can see how it's working. I just absolutely love it. So, okay. This is good. This is the latest one. Her hand is back on her head, right? The head's big, but it's trying to figure out how to do it where you keep the image in line, but still have everything like the hand, but also have a big head. And I think it's doing a pretty good job on that. Okay. It's keeping her identity pretty well. Nice. Come over to this one. Okay. It's not the guy anymore. It looks like it is that girl. Hey, it's zoomed in her face, but it's really cool because one, this head's way too big. I mean, that's not how big the head needs to be. But it has all the compression artifacts on her face from as if it literally just cropped it out, blew it up. But it's kind of understanding. And another thing is I think on the prompts we have make their head bigger instead of make everyone in this group's head bigger or make the girl in the red sweater's head bigger. So, once we have the LoRA done, we can play with that a little more. Let's look at the next one. This one, it just doesn't recognize a head. So if we really wanted to make this LoRA more robust, we could add in, where we manually do some people in masks, do some group shots, things like that. But that's fine. This is kind of a control. This guy, his head went back down. So not sure what's going on there. But it got bigger for a second. Now it's getting small again. That's fine, though. Okay, her head starts out small. It's getting big. Hands got bigger, too. The head's more proportional. See, at first it was kind of squished. So it's just bigger here. That's good. This front head's still not doing anything. The old man, yeah, he's got a nice, smooth transition, getting bigger and bigger. His headphones are getting bigger. He still has a lot of his identity. Give me more samples. Here we go. So from before, now, head's a little bigger. It has that girl's head more of her hair. I cannot believe how it's literally cropping this out inside the model and just repasting it bigger here. I can't believe it can do that. I mean, this isn't what we're going for. That's impressive how it's working. And it makes me think of there's a lot of other cool stuff you could do, like zoom into this person's face. You can make a whole data set on that if anyone's looking for ideas. It's real simple. Crop the image, zoom into the person with the red shirt's face. Not very useful, but doable. Okay, we're seeing, kind of looks like he has a Guy Fawkes mask mix on this. I don't know, but it's at least affecting his face now. Before it wasn't really doing anything. Something's happening. Yeah. Big head, good. I was worried this guy wasn't gonna play with the team, but his head's getting big. Nice. Also, man, look at that detail. It is getting the logo on his hat and just blowing it up. Super cool. This girl the image is actually moving a little bit, but not much change there. His head's getting bigger. Cool. Hey, you. There's more samples. Take a look. Go through them kind of fast. Bigger head. Good. Still expanding that girl's head out to here. It's covering up this guy's head, so it's that is his head. I don't know. Looks horrible. Hey, we're getting some enlargement on Skeletor. Nice. Please keep going. Big head on that. Loving it. Getting bigger. Loving it. Getting bigger. Loving it. Give me more. Okay, we are at 1,500 steps. Take a look at the samples real quick. I mean, everything's looking pretty good. That one's, not. This one, it went back down. It's fine. Head staying big. Head staying big. Head staying big. Okay, I think we're going to stop here. I mean, if you're going to train like the best you can do, you may want to keep going. What we're doing for the video and for big heads, it's getting the concept. We're going to stop it here. So we can just come up here, pause it, stop. Takes it a second to stop. And then we can download the LoRA right here. Here's all your different ones that you have cached. So 1,500. We're going to download that one. Let's load it up in Comfy. Let's try it out. Let's see how it works. We have the LoRA downloaded. We loaded up Comfy. Here we are. Built a basic workflow. I can share a link to this, but it's not super complicated. It's basically just Flux. There's one new node. Make sure you have to update Comfy to the latest because they just kicked this update out yesterday. I do it a little different. Scaling image to total pixels here. But this reference latent, this is the new node. Other than that, it's about the same as Flux. Just here's your reference latent. Feeding that in, run that through the bay. We have this, give this person a big head. We have Willy Wonka right here, the original with Gene Wilder. Let's run it, see what happens. Nice, delicious, big heads. I love it. I mean, it kept his identity completely. It literally is just cropping out the image and zooming it in. Not perfect, but it's doing it. I want to try a few other things. Let's try this painting. I don't know if it's going to work. We'll try it. And it's actually working. I mean, it actually did it. It knows that's the face. Okay, let me dig through a couple more images here. Oh, I know what we need to try. Okay, so we have the group photo, right? You guys remember this one? It kept failing. It was doing that one girl's head all big. So let's try this. Give everyone in this photo a big head. Nice. It works. So that was it. We just needed a different prompt. I don't know. Actually, I don't think this is this person. Yeah. That is not that person. That's this guy. But hey, it did a pretty good job separating them all out, giving them bigger heads. I mean, I will take it. Let's try the Skeletor one. I'm going to try that one out as well. Except this time we're going to say something like, give the person wearing a Skeletor mask a big head. It cleaned up the Skeletor. That's not the Skeletor anymore. That didn't work. Let's try something else. Let me go through. Got to do some memes. Oh yeah, love it. It blew up his face. I mean, it's bigger. And it has all the compression artifacts in there still, but it actually just enlarged his head. Oh my gosh, I love it. Oh, here's one. It's from a video I made. Perfect. I mean, I'm really impressed with how good this is actually working. I have another one. Let me see if I can find something. Okay, here we go. It did it. Okay, let's see if we can give everyone a big head. He's looking back because he likes that big head. No, it's not getting everyone. We need to do more groups. But hey, we have the lady. She has a big head, and that's really what makes it great. So guys, that is how you can train a LoRA with context. I think this opens up a whole new door of things that we can do. I mean, because if the model doesn't do it great on its own right now, like it didn't do at all with the big heads, you can teach it how to do it. And that opens up just so many possibilities. I can't wait to see what the next few months brings and how creative people can get with this. And hey, if this video was helpful and you learned something, or maybe you just use AI Toolkit, give this video a like, hit subscribe. That helps out a ton. If you want to help out even more, go check out ostrich.com/support. I rely 100% on donations for all of the work I do. You can come here. You can support me on Patreon, GitHub sponsors, PayPal. Every dollar counts. Look at these beautiful people who are currently my supporters. Thank all of you. And your name could be up here amongst the greats. That's it. I'm Ostrich, and I'll see you guys next time.